Hello everyone, welcome back to another video. This video I will be going over what I have accomplished in the past couple of months. I do believe I've made quite a bit of progress. So it has been a while since I've uploaded my last video, so I do apologize for that. I've been really busy with cross country, with cross country running. Now we're in winter training, and so running takes up a lot of time. School takes up a lot of time. Homework takes up a lot of time. And whenever I'm not doing that, I'm working on my project, which I will talk about more in another video. So to start off, I will go over the racecar gym. With the racecar gym is a GitHub repo, which I did post a video of me running it. It was a 3D environment for testing decision tree algorithms, and what I did was the way I found out about it was I was talking to a professor at Iowa State University, and he sent me code and repo with decision tree and XG boosted algorithms models that him and an associate developed. So most of the work and problem solving that went into that was figuring out the GitHub commands, as I was not super experienced at the time using GitHub. I'm still not very experienced, but that was where most of the problem solving was for me. That's where most of the difficulty was. It was I had to do a lot of working around errors in terminal. Mostly a lot of it was also due to dependency version friction. So I didn't have the right stuff installed. I had to install Docker, which wasn't. There's just there's you go through the instructions. It wasn't. There's just like small problems coming up, and then just like they compound. And that all took probably longer than it should have, but I did get their decision tree and XG boosted models running in the racecar gym repo, so locally on my computer. So that was a lot of fun. I posted that in my last video. I also did have to learn a little bit about how the models worked, to figure out what commands I need to run, what configurations, how to train, and how to simulate which files to use, which files to run. And I also looked into their code and learned about how the algorithms worked. And also I looked into their research paper. So moving on from that, I did get in touch. The professor at Iowa State University did get me in touch with the technical director and executive directors of the Iowa State University FSAE team. What FSAE is it's like like college. If colleges competed like in a mini Formula One, they build cars. The teams from the universities, they build cars and they compete in different events and tests. So I set up a Zoom meeting with them, and they shared a lot of very interesting and useful information. The reason I initially wanted to talk to people in the FSAE team was because I was looking. I was and still am looking at working on projects that involve simulation and preferably have something to do with mechanical engineering or vehicles, because I am just trying to find something I'm interested in and something I can get excited about, some project I can get excited about. And I am working on a project which I think is very interesting, which I will talk about more in my next video. But I had the Zoom meeting with the technical and executive directors, and they told me a lot about what kind of software they use. What kind of software they use. They also offered to give me feedback on project ideas to help me like narrow down what I want to work on. So some of the software they mentioned would be good to learn is SolidWorks or Onshape, ANSYS, FEA, Star, CCM, MATLAB, and Python. So I do still need to look into those. I do have experience in Python. I took a year-long AP computer science principles class in Python, so I do have some experience in that, and I do need to look into the other softwares. I think I might start with MATLAB. So they also talked about the subsystems, different the different parts of the team that that work on different parts of the car, developing the car. So the different roles are suspension, or different roles or parts that go into developing the car are suspension, controls, chassis, aero, electrical, powertrain, final drive, like differential and motor mounting, hubs, and business. So I think it's really I am also looking for any small problems I can solve. So that is why I was kind of like digging for to get into the details and try to find some small problems, or like where problems usually arise, and where I can look and potentially find some sort of project that's like applicable in real life, and that would actually be useful. I think that would be that would for me, that's what would make a really good project. So they also talked about their validation methods for simulation, because I'm also very interested in simulation, what kind of like simulation software they're using, and how they validate the results that they get from the simulation software, to check that what they're seeing is real data that's like going to like apply in the race, that's going to actually be useful and accurate. So they said they use strain gauge testing, on the suspension, shock pot data with and without aero, brake thermal analysis, wheel force transducer data, and observing failure modes when testing. So those are the main points, I think, of what they told me about the team and how they developed the cars, and that was very interesting. And in the next video, I will share what my project is. I do have a GitHub repo now with all the code documented, so yeah, and I will talk more about that in my next video. So thank you for watching. I'll see you in the next one. Thank you.